Okay, hello and welcome to the first video of many where we'll be looking at different problem-solving questions which will help you understand how to tackle them, how to approach them, how to read them, and most importantly, how to execute all the skills that you've learned in the course thus far to solve them. Okay. So today's video will be the focus of today's video will be quadratics. We're looking at 3 questions ranging in difficulty from bronze to gold, and on each slide I will be going through the question and helping you understand how to tackle them. So here are the 3 questions. Okay, so you've got bronze level question there, 3 marks. You've got silver level question there, again 3 marks, and gold level question there, 4 marks. And as you can see with the difficulty level, the bronze level question is staged a bit more with part A and B. The silver level question, not so much, and the gold level question looks a bit more complicated. But hopefully we should be able to do all this fairly easily as long as you can recall the important skills from quadratics. So here is the first question, okay, that we need to use. Okay, so I'm just going to use my little thing here. So what we've got is an equation, a quadratic equation, 2kx squared plus 4x plus k, where k is a constant. Apparently this quadratic has 1 repeated root. So if it has 1 repeated root, that means that the discriminant, and you have to remember the 3 scenarios, the discriminant is equal to 0. So the discriminant of this quadratic given to us is equal to 0. What you then have to think about is, okay, I have to use a discriminant. What am I going to substitute in for A, B, and C? So you need to look at the values of A, B, and C and substitute them in. And I would highly recommend use of brackets. So if I look at my quadratic here, I can clearly see that my B is the coefficient in front of X. So it's going to be 4 squared. And look at my use of brackets, okay? Then I've got A, which is the coefficient in front of X squared, which is going to be 2k. Then I've got to multiply that by C, which is the number right at the end, which is k. So once I put all that in, what do I need to do? In part A, I need to show that we can get to this stage. So if you sort of look at this question, it's not really clear for some students when they read this how they can get from that to that. But again, you have to bridge it with the use of discriminant. So 16 squared minus 8k. Oops, sorry, put that wrong there. I should be writing 16 squared. There you go. It just should be 16. Let's get my pen again. Here we go. So minus 8k squared equals 0. And that means 16 is equal to 8k squared. K squared is equal to 2. And that means k is equal to plus or minus root 2. Never forget that plus or minus, okay? So those are basically answered the whole of part A and part B there, okay? I've, managed to show this expression, and I've managed to solve to get the value of k, or the 2 possible values of k. So, this is a very straightforward discriminant question. Not a lot to do here, and it's worth only 3 marks. But again, the key word is the 1 repeated root. That has to really be in your memory as to how this links up with the discriminant. Okay, as long as you can understand that, you'll be fine in terms of breaking the question. Let's move forward then. Now we've got the silver question here. Another quadratic. It looks slightly different. We don't have k, we've got p. P is a non-zero constant, so p cannot have the value of 0. But apparently this quadratic, and this is a quadratic, 3x squared plus a number x plus a number, has equal roots. So again, if it's got equal roots, you then have to think about which of the discriminant situations would apply. And if a quadratic has equal roots again, you know that discriminant must be equal to 0. So let's put in what we know. Okay, so I'm going to put in b as, well, look at this, it's the coefficient in front of x. B is going to be p, so p all squared. Even I'm using brackets here, just so that I'm very careful. The value of a is going to be the number in front of x squared. So 3 times by c, which is whatever's at the end, the number at the end, times by 2p equals 0. So you get p squared minus 4 times 3, 12, minus 24p equals 0. Now we get to this stage here, and some students, they think, okay, I've got to this stage, how am I going to get the value of p? Well, look at this. This is clearly a quadratic in p. Okay, now what you need to do is to factorize this. Okay, or you can solve it by taking the 24p on the other side. However, I would just go straight into factorizing it. Okay. Now, when you get to this scenario, again, to get the values of p, you have to remember when you factorize and solve quadratics, in this particular form, either p is equal to 0 or p minus 24 is equal to 0. Now, from this, what we can gather is that p is equal to 24 is one particular solution we could have, or p is equal to 0. Now, if we read the question, there is only a value of p. They're not saying values, and p has to be non-zero. So out of these two values of p that we've got, clearly p equals 24 is the final answer. Okay, we will not accept p equals 0. In fact, we can even explicitly put a cross through that to say that we're discounting it. Okay, so one thing that you have to understand with these sorts of questions is that, the quadratic, you solving this quadratic here in p, the quadratic does not know the context it's in. So it does not know, it does not decide for you which of these p's you accept or not. Okay, you have to decide based on the context it's in. Okay, that's the silver question. Here's the gold. So clearly, when you look at the gold, it's not staged at all. We don't have any part A or part B. The quadratic, or the expression given to us in the bronze and silver, is quite clearly a quadratic. This one, however, is written in a slightly different form. Okay, so we need to sort of deal with this quite calmly. We've got an equation. Okay, this an equation here, where again we've got another constant q, and apparently this equation has one repeated real root. Find the two possible values for q. Now, again, if you think about silver and bronze, what were we doing? We were doing the same thing. We're applying the discriminant b squared minus 4ac onto a quadratic. This does not look in the form of a quadratic. The form of a quadratic is normally ax squared plus bx plus c. Okay, that's the form that we'd like. So let's try and get it into that form. And how do we do that? Let's try and get rid of this fraction. The best way of getting rid of a fraction, especially you've got an equal sign and something on the right hand side, is to multiply through by the denominator. So you've got 3 minus x squared equals q times x plus 2. Therefore, we have qx plus 2q, 3 minus x squared. Okay, now there are a variety of ways I could do this. I could either put the right hand side items onto the left hand side, or left hand side items onto the right hand side. I always prefer to have a positive x squared. So everything that's on the left hand side I'm going to take to the right hand side. So I'm going to have x squared plus qx plus 2q minus 3 equals 0. Okay, so that's the expression I can get. And if you look at this, this is a quadratic. Okay, what we've got here, we've got 1x squared, we've got qx, so that's our b, and then we've got this 2q minus 3. That's clearly going to be our c. Now, we've got our quadratic in the form ax squared plus bx plus c, and it's equal to 0. So let's see what they've given to us in the question. They told us that apparently this has one repeated real root. So again, like we've done the previous few questions, one repeated real root, that implies the discriminant is equal to 0. Okay. So let's put in what we know into A, B, and C. A is clearly going to be 1. B is Q, so it's Q squared minus 4 times by A, which is 1, times by C, which is 2Q minus 3. Oopsie daisy. 2 cubed minus 3 equals 0. I'm not quite sure what happened with the writing there. Okay. And so you're going to get q squared minus 8q plus 12. You've got to be very careful with your expansion of brackets, okay? It's very easy for students to get the wrong sign here. Look, minus 4 times 2q, minus 4 times minus 3 plus 12. Okay. Now, what I'm going to do, sort of compromise my space a little bit. I've got a quadratic in Q that I need to solve. Okay, so I could use my basic skills of factorizing. Yeah, I mean, this is GCSE equals 0, and therefore Q equals 6 and Q equals 2. These are possible answers or values of Q. Now, how can you check if that's correct? Well, what we could do is you could put those Q values back in. So let's say I put a Q value of 2 back into this expression. I'll get x squared plus 2x, 2 times 2, 4 minus 1, so that's 1. And let me check if this produces one repeated real root. If I factorize it, yes, it does. I have one repeated real root. So yes, these values are correct, and I can check it by putting it back in. Okay, so I've done, all 3 questions here on this problem-solving worksheet from bronze to gold, and from this you can probably understand the skill sets needed for each level of difficulty. Okay, so I'm going to stop the video here, and thank you very much.